Hello. Hi, everyone. Thanks for coming. Last session of the day. I hope y'all are still awake. So today I'm going to be talking about accessibility, .NET MAUI, accessibility in .NET MAUI. And before I get started, just a little bit about myself. I'm Rachel. I'm a software engineer at Microsoft. I joined around 2 years ago when we were still Xamarin Forms and just getting started on the .NET MAUI journey. And I love eating, reading, exploring Boston. I have a Foodstagram. If you're on Instagram, you can follow me. Namanayam, shameless plug. And I love all things accessibility, mobile app development, tech for good. This is my space. So yeah, you can find me on Twitter, GitHub. If you prefer to follow along on your own devices, I've already uploaded the slides and my demo on my GitHub, so you can check it out there. So yeah, let's get started then. The journey to accessible apps with .NET MAUI. So I always like to first start off by reminding ourselves why we're talking about this, why we care about accessibility. So over 1 billion people currently experience some form of disability. And at Microsoft, we have a tool called the Persona Spectrum to help us understand the wide range of disabilities that people experience. So they can be anywhere from permanent, temporary, to situational, span across different abilities to touch, see, hear, speak, and so forth. And despite different scenarios and different situations people have, you can see how people in different situations can benefit from the same solutions. So for example, someone who is blind and someone who is a distracted driver can both benefit from a GPS that tells us where to go out loud. So you can see that designing for accessibility is not limited to people experiencing disabilities. It's the best solutions benefit everyone. We see this all around us. We see it with closed captioning, live captions. We see it with the raise hand feature in Teams. This is an example of a feature that was initially designed with neurodiversity in mind, but it's something that we all benefit from. There's, of course, dark and light modes and various device settings. And even in our physical world, things like dropped curbs were initially designed with accessibility in mind for wheelchairs. So yeah, if that's not enough, it's also a huge business opportunity worth hundreds of billions of dollars. And there are also a growing number of legal consequences that you can face if you don't have accessibility in mind. So what can we do about all of this? I'm hoping you all are here to approach our apps with accessibility in mind. So when it comes to approaching accessible apps, empathy is truly the name of the game. I'm going to be talking a lot about different APIs, tools, and resources we have to help us approach accessibility better. But at the end of the day, it's all about empathy, putting ourselves in the shoes of our various users and their different scenarios. So of course, we can help build our empathy by exploring different accessibility settings and features, researching various models and APIs, testing our apps, and leveraging our available tools and resources. So with .NET MAUI, you'll be able to create accessible apps more seamlessly than ever before. Our team has been putting a lot of work into this, and we still are. We have a bunch of PRs and more that are not shown here. And so I can talk about this all day, but let's see just 10 awesome things about .NET MAUI accessibility. So number one, this is in no particular order, by the way. I love all 10 equally. But number one, semantic properties. So we have a set of new APIs called semantic properties that allow developers to indicate what they want screen readers on their devices to read aloud. So whether or not you can actually see what is going on your UI visually, you can hear from the screen reader the interface. And so the properties we have semantic properties at description, hint, heading level, and you can see here an example of how description is being used either in your XAML code or in your C# code behind. You can very easily set the semantic properties, and I'll go more into this later. We also have other semantic APIs. We have semantic extensions and other screen reader APIs. So we have one called Set Semantic Focus that allows us to indicate if we want a specific control to receive the screen reader focus. We also have a semantic screen reader.announce method that allows us to indicate a specific string to be read aloud, and it doesn't necessarily have to be associated with specific control as the semantic properties do. And of course, if the semantic APIs aren't enough for you, we also have our amazing community toolkit. So we have Xamarin Community Toolkit if you're still on Xamarin Forms, and we also have new .NET MAUI Community Toolkit. And so if you're still on Xamarin Forms, we have semantic effects, which are essentially a variation of semantic properties. So you can check out these new APIs in Xamarin Forms as well. And then there's semantic order view, which is available both in Xamarin Community Toolkit and MAUI Community Toolkit. And this is a better approach to ordering in our apps. So normally speaking, our screen reader will read out the elements on your screen in a logical order, just in the order you see it. But there are certain special scenarios where you might want to have the controls be read aloud in a not so intuitive order, depending on custom controls and things like that. And so we have this semantic order view that allows you to indicate the special type of order. Number 4, app theming. So of course we have light mode, dark mode. You can set this in your styles. You can define your own app themes, and this is important for people's different visual preferences. And so something like this is something you might take for granted, but if your app doesn't take your system's services in mind and kind of account for that proactively, it won't work automatically. But with .NET MAUI, we thought about these things. So app theming is an example of something that just works. Number 5, on that line, we also have font auto-scaling. So on your device, if you change the font size that you want everything on your phone to be rendered as, it'll just work because we've accounted for that on our mobile devices. And if for some reason you don't want it to work and you want something to stay the same size no matter what, we also have a font auto-scaling enabled property that can be set to false. Number 6, built-in accessibility. So I was talking about semantic APIs earlier, and that's things that .NET MAUI developers can leverage in order to make your apps more accessible. But beyond those APIs, we wanted MAUI to just be as accessible as possible right out of the box. And there are a bunch of things we have done to make that possible. I just wanted to highlight a couple of those things. So one example is with tap gesture recognizer. So if you have a control and you set a tap gesture recognizer to it, that control becomes tappable. Great. But previously, in terms of accessibility, the screen reader wouldn't recognize that control with a tap gesture recognizer as something that is tappable. But we have added code to MAUI to ensure that that gets recognized as a button, since essentially that control is now acting as a button. We have another scenario here where checkbox, we made it read aloud as a switch. So checkbox is a control that we have this type of scenario in MAUI a lot, where because we have these cross-platform controls, we create controls for certain platforms that don't natively already exist. And in those situations, we also need to account for making sure that they become natively accessible. So in this scenario, we made it read aloud as a switch. Number 7, customization via handlers. So something super exciting about MAUI and super awesome about it is that if all of our APIs and all of our community toolkit offerings aren't enough for you and you want to go above and beyond to really customize your app, you can do that. You can access the individual handlers for the specific platform. So we have our cross-platform controls, but then we have handlers that map down to the platforms for Apple, for iOS, Android, Windows, etc. And we enable you to access these so that you can customize your code however you want. You can use conditional compiler directives in order to insert your custom code like this, and I'll be showing you an example of that soon as well. But really, the world is your oyster. 8 accessibility standards. So the cool thing about working on .NET MAUI is that we are part of Microsoft, so everything we work on complies to Microsoft accessibility standards, and that also comprises of complying to the Web Content Accessibility Guidelines, among other things. And Web Content Accessibility Guidelines have become kind of the global and legal benchmark for accessibility for both web and mobile. And it's based on these guiding principles that all apps need to be perceivable, operable, understandable, and robust. And you can get into the nitty-gritty details. There's pages of documentation on exactly how you should abide by these guidelines and different levels of accessibility and all that. So, yep. And then 9, we have a tool called Accessibility Insights at Microsoft. This is also publicly available for anyone to use. I think currently it's only supported on Windows and Android. But essentially, you can use the tool to run your app, and it'll tell you what isn't accessible about it and quickly identify those points for you and give you recommendations for how to improve upon it. So this is an example of one of the earlier iterations of our MAUI template app. And the Accessibility Insights told us it's not accessible because the color contrast between this purple robot and the purple background was too low. And so we changed it to a white background, and now we have a happy, sleepy cat. But beyond our template apps, we wanted to make sure that .NET MAUI really is accessible when you create a more involved app. So I created also a recipes app that is more involved, and we had accessibility vendor team formally validate our app super thoroughly, and they reported issues such as this one, and we made sure to fix all of them. So yeah, .NET MAUI is super accessible. Before I get to number 10, we're gonna do a demo now so I can show you all of these things that I've been touting. Alrighty. So, that's not showing. Okay, having some technical difficulties. Let's see. Yay, okay. So here I have a MAUI app. This is just a file new MAUI app. It's blank. There's nothing going on here yet. How many of you are familiar with .NET MAUI? Okay. How many of you are familiar with accessibility in .NET MAUI? Okay, awesome. All right, so we have our file new MAUI app, and right out of the box, we already have some semantic properties here. Can everyone see this? Okay, I'll zoom in a bit. Alrighty, hopefully this is a bit better. I'm gonna close this because we don't actually need it. All right, so we have our file new MAUI app. We have semantic properties right out of the box. So you see we have stack layout with an image, of a .NET bot. We have semantic properties.description saying cute .NET bot waving hi to you. We have a label. It's the only thing I've changed so far. So it says hello DevReach instead of hello world now. I've set a semantic properties.heading level to it of level 1. So the way that this property works is that we have values from level 1 through level 9. And the reason why we've done that is because on Windows, there are 9 different heading levels. On mobile, it's just a Boolean if it's a heading or not. So if you set a heading level, any heading level to it, on mobile, it'll just interpret that as the heading level is set to true. Then we have here another label, heading level set to 2, description saying, welcome to .NET Multi-Platform App UI, which is exactly what the text reads, but you can see I've written it slightly differently. And the reason why I've done this is because I don't want there to be any chance of the screen reader to misread what I wrote. I don't know how they're going to interpret this period or the all caps net, so I just wrote out .NET. Similarly with UI, I wasn't sure if the screen reader is going to try to attempt to read UI as a single word, which is why I separated it out like this. And then I have a button here that counts the number of times it is clicked. And if we go to the code behind, when that button is clicked, you can see that it's incremented, but also we have the semantic screen reader that announce API that's being used, and it announces the actual text of the button. So let's see this in action. All right. It's a bit big. Okay, so I have here an Android device. I like to use physical devices, and I think everyone should when you're working with accessibility. It's the easiest way to understand your users, empathize with them, and of course also to use screen readers. So I'm going to click on the app I have here already running, and you can see what I was showing you. We see the .NET bot, we see the Hello DevReach, welcome to .NET Multi-Platform App UI, and we have a Click Me button. I'm going to turn on TalkBack now, which is the default screen reader on Android, and I'm going to click through the various controls so we can see how the semantic properties play out.
TalkBack on. DevReach demo. Home.
So I'm going to click on the image.
Cute.NET bot waving hi to you image.
So you can see that the semantic properties.description we set gets read aloud. And then for text controls, even if we don't set a description explicitly, it knows that we should read that out loud. So
hello, DevReach, heading.
Hello, DevReach. And then it says heading because we set a heading level to it.
Welcome to .NET Multi-Platform App UI, heading.
Same thing with welcome to .NET Multi-Platform App UI. It gets read out exactly as I specified it to. It tells us it's a heading. And last but not least with the button.
Click Me button counts the number of times you click.
It
double tap to activate.
Since we set a hint to it for telling us what the button does, it does that for us. And then when I click the button, the text should be announced since we use the semantic screen reader .announce method. Let me try that again.
Click 2 times.
So it tells us it's been clicked 2 times. Okay. I'm going to turn this off now so it doesn't go off. All right, so I'm going to jump back into the the code. So you can see that was just a file new MAUI app. Right out of the box, we have all of these cool things working for us, and you have a model for how to add semantic APIs to your own apps. All right, I'm gonna make this a bit smaller again. So another thing I had mentioned was that tap gesture recognizer thing earlier. How if you have a control that's not a real button, so for example, I have this label here. It's not a real button, it's a label, but I wanted to do exactly what a button does. And this is helpful in scenarios where you have custom controls and you have a particular idea of what your button looks like, and it goes beyond a normal MAUI button control. So we have this new label I've created called counter label. You can see it's essentially has the same exact properties as the button. I have the same hint. I tried to make it look the same. You'll see soon. And then in the code behind, I'm going to create this onCounterLabel clicked method. And when it is clicked, I want it to do the same exact thing as the counter button. So you can see the button, we had it increment, we had it announce the text. I'm doing the same thing here, but I've added a tap gesture recognizer since we're using a label and it's not actually a button. And I'm going to have the semantic screen reader announce the same exact thing. So you'll see that it acts the same and that it'll act as a button. And we know that because at the end of all of the hint and the text being read aloud, it tells us double tap to activate. And that's something that the Android platform only does if the control is an actual button. So I'm going to run the app again. And we'll see this going. While we're waiting for this, does anyone have any questions on anything so far? Cool.
Yeah, question in the back.
Oh.
I'm not sure if this is something that would be going over later, but does the when using MAUI hybrid with Blazor, are there also does this accessibility stuff, or are there accessibility options for that as well?
Yeah, so it's going to look a little bit different, but there are accessibility features there as well. As I mentioned before, since at Microsoft we have our Microsoft accessibility standards, and all of the .NET teams and other teams go through the same process of getting validated for accessibility. I know the Blazor team is doing the same exact thing. As for specifics, if you have questions later, feel free to let me know, and I can definitely find the person who works on accessibility on the Blazor side. Okay, so it's deployed. You can see here now we have a second button, the one we just created. That's actually a label with a tap gesture recognizer. And I'm going to turn on TalkBack again, and we can see how it's read aloud exactly the same, including that double tap to activate that we haven't indicated anywhere, but we just have done that behind the scenes for you since it is a button.
TalkBack on. Held volume keys. TalkBack turned on. DevReach demo. Home.
All right, so I'm going to click on the button.
Click me button counts the number of times you click. Double tap to activate.
So you can see after a brief pause, it gives us more information on how to interact with that control. It says double tap to activate. Similarly with the label.
Click me counts the number of times you click. Double tap to activate.
We get the same exact behavior.
Spoken language. Swipe up or swipe.
All right, so I've turned TalkBack back off. Now, one more thing I wanted to show you was the handler stuff I mentioned earlier. So I'm going to stop this, and let me see if I have my... Okay, so recently someone opened an issue in .NET MAUI. Let me see if I can find it. I thought I had it open, but alas, I do not. Okay, here it is. So they opened this issue. They said that the tab button doesn't work when you shift the button from the last button. So I looked into it and I figured out what they were talking about. So they were saying that on the Windows platform, if you have multiple buttons and you use your tab key on your keyboard, normally it the focus, the keyboard focus, goes from the first button to the next button, and that's normal. But they were expecting also from the last button that it would cycle back to the first button if you click tab again. I checked with the Windows platform, and that's actually not the default behavior, and so naturally that's not the default MAUI behavior either. But I was wondering, okay, is there a way that we can make that work though? And I learned that there is a API on Windows that allows you to do that, and it's not something we offer on MAUI yet, but we can use our handlers to do it. So there's this property on WinUI called tab focus navigation, and you can set this enum value to it. So the default is that if you want to go backwards, you have to shift tab, and then when you go forwards, it's just tab. But if you wanted to cycle back by clicking tab from the last to the first button, you can do that by setting this property to cycle. So I decided to do that with a handler. So you can see here, I created a method to modify the tab navigation, and we are using a handler to map into this Windows API for tab focus navigation. And you can see here I'm using the Windows compiler directive since this is just a Windows API. And I've set the keyboard navigation mode to cycle. So let me actually comment this back out. Comment everything back out so I can show you how it works on Windows as I was explaining before the handler, and then you can see it working. Ready? Just gonna comment out the label stuff. All right, so I had the original button and I just copied it. I have the same exact button here. So we have two of the same button. I'm gonna use our awesome multi-targeting to switch to my Windows machine and run this on Windows now. Yay. All right, so now we have the same app on WinUI. And when I click on the tab button on my keyboard, I accidentally hit caps lock. Okay, tab. You can see that there's this black outline that goes on the click me button. And if I click tab again, it goes to the next button. But if I click tab again, it just doesn't do anything. It doesn't go anywhere. So this user wanted it so that when we click tab again, it'll go back to the first button. As I was saying, the default is that it works when you use shift tab, so that's how you go backwards, and then tab goes forward. But we wanted to use tab to cycle back. So we have our handler code. So I'm going to comment back in this code that I was mentioning. The handlers, our awesome compiler directive, and this cool tab focus navigation API, which I didn't even know was a thing before this. Okay, so I hit tab again, and it just keeps going. So that's how you can use our handlers to do super awesome things that you can't normally do, that we just haven't gotten to yet. Alrighty, I think I have some time, so I want to show you the semantic order view thing that I mentioned earlier with the community toolkit. So have it here on Android. I'm going to go back to that slide so we can remember exactly what I was talking about. So I mentioned that we have in Community Toolkit a semantic order view that allows us to indicate the order in which we want the controls to be read aloud. And so basically when we have screen reader on mobile, you can use one finger to touch swipe through the elements. Normally it'll go in the order in which you've implemented those controls. So normally you can see here, it would read out the second, third, fourth, fifth, and then first. But with the semantic order view, you can indicate your own arbitrary, but hopefully still meaningful order. So I have here an example of semantic order view just from this label to second. Label reading second to this button reading first is in the semantic order view. This button here is not, so it'll actually go here first, but then we'll expect it to jump down to first before going back up to the second label and then through it. So I'll turn talkback on.
Talkback.
So
Element outside the semantic view button.
we start with the element
Speech rate.
outside the semantic
Swipe
view.
up or swipe down.
And then we are going to go
First button.
first.
Double tap to activate.
And then we're going to go to the label back up to second.
Second.
And then we go down to just in order the way we have it here.
Third button.
fourth, and then the fifth and last.
button. Spoken language. Swipe up or
So yeah, that's our semantic order view, and you can use that in Xamarin Forms and also in .NET MAUI. All right.
Okay, Rachel. Do you have to express your ordering in C# or can you do that in Xamarin too?
I think at the moment just in C#. Yeah, but the thing is, most of the time you won't need to use something like semantic order view. The order that you have implemented everything in XAML, that is the order in which your screen reader will read things out loud. All right. So last but not least, let's get back to number 10. The journey continues. So as I showed you, we've implemented a lot of things with regard to accessibility, but obviously there's always still a lot more work to be done. So we're constantly working on it. We have some awesome documentation online just about our semantic APIs for you to check out if you ever want to learn more about them. I also have a blog post series all about this journey to accessible apps that you can check out. And of course, we're on Discord and we have a MAUI accessibility sub-channel. So if you ever have any questions, ever want to learn more, please join us. We also have monthly chats just on accessibility in .NET MAUI, and I'd love to chat more with all of you on Discord, Twitter, GitHub, wherever. And that's all. Thank you.